Okay, this is the first video in the Chapter 10 Ghost Lesson playlist. It is going to introduce the idea of a sequence and talk about the types of sequences that we are going to be looking at in Algebra 2, as well as how to recognize those particular types of sequence. So, first off, a sequence is a set of numbers that are in a particular order. This is why we didn't have this situation come up earlier in the class when we discussed sets, because those did not have to be in order. In this case down here below it, you'll see an example of a sequence. You should notice that there is a pattern to these numbers as they are increasing by 4 every single time. In other words, there is an order to this chaos, and everything fits a specific, predictable pattern. Now, sequences come in two different forms. You have finite sequences and you have infinite sequences. The difference between the two is that infinite sequences will go on forever, whereas finite will end. Something like 2, 6, 18, 54. That would be an example of a finite set where the pattern, again, is consistent. We know what the pattern is, so we can predict each term. Now, in this Algebra 2 class, we're going to be talking about two types of sequences. We have arithmetic sequences, which are sequences with a constant addition or subtraction, because I don't know why I'm putting parentheses around that. Constant addition or subtraction pattern. In other words, we will add the same amount over and over and over again. The other type that we will talk about in this class is geometric, which has a constant multiplication pattern. Now, multiplication would also fit the bill for division, because division is just multiplying by a fraction. So, these are the two types we're going to talk about. Arithmetic patterns, which are a constant addition or subtraction pattern, meaning we add or subtract the same amount every single time. And geometric sequences, which are a constant multiplication or division pattern, because we're multiplying by the same amount over and over again. In the case of division, we would be multiplying by a fraction. So let's do some examples of telling those apart. Here are three sequences. The directions are very clear. Determine whether the sequence is arithmetic, geometric, or neither, and explain your reasoning. So, we look for a pattern. If we look closely, we will see that in this particular sequence, we are adding 5 over and over and over again. This is a constant addition pattern. So this is an example of an arithmetic sequence. So we would say arithmetic. And then as for the explain your reasoning, we would say constant addition pattern. And that would more than explain how we know that that is an arithmetic sequence. The next pattern, we have an addition of 2, and then an addition of 4, and then an addition of 6, and then we add 8. So while there is still a pattern, that does not fit either one of our descriptions. This would be an example of it is neither arithmetic or geometric, and our reasoning is that although there is an addition pattern, it is not a constant addition pattern. Constant is a very key word when we are looking at whether or not a sequence is arithmetic or geometric. It has to be a constant addition or constant multiplication pattern. If we're not adding the same amount every time, then it doesn't fit the description. On letter C, the pattern is not addition based, it is multiplication based. Every number is twice the previous number, so we are multiplying by 2 every single time. That makes this an example of a geometric sequence because it has a constant multiplication pattern. Okay, so let's do a couple more. There are 3 more on the next screen. We're going to do those as well. In letter D, again, we need to spend a second and look for a pattern. Hopefully you've paused the video and tried these 3 on your own from a blank copy of the notes. If not, the pattern here is very clear. We are subtracting 4 each time. Now keep in mind that that is the same as adding a negative 4. So this is an arithmetic sequence because we have a constant addition pattern. Okay, subtraction is just adding a negative number. So if we have a constant subtraction pattern, that would also fit the arithmetic description. On letter E, we have a constant division pattern, right? Now, the way that we're going to write that, though, we're not going to write it as division. We're going to write it as multiplication by a fraction. So since we're dividing by 2, that is the same as multiplying by 1/2. So that is a geometric sequence because it has a constant multiplication pattern. Finally, our last example is actually kind of a tough one to spot for some people. It is a multiplication-based pattern. However, it is not a constant multiplication-based pattern. So first we multiply by 1/2, or divide by 2, whichever way you want to look at it. And then we multiply by 1/3, and then by 1/2 again, and then by 1/3 again. This is not a consistent pattern. It's not a constant pattern. So that is a neither. Even though it is a multiplication-based pattern, it is not a constant multiplication pattern, which is how we explain how we know that it is neither. That's it for the first video. Our next video will explore arithmetic sequences in significantly more detail.